All right, so we're getting into Unit 13, and this is 13.1, parallel and perpendicular lines on a coordinate plane. So after today, you should be able to plot them, identify them, and identify if they are perpendicular or they're not perpendicular given an equation. All right, we're going to get a little bit into algebra again, and you should be able to identify an equation in slope-intercept form and be able to shift them around the equations, that is, if they are not in slope-intercept form. All right, so let's get a little bit of algebra review, and we'll say that we are given an equation negative y equal, or so we'll say that y, I better move that because I know where it's going to end up being. All right, we're going to say that y equals negative 2x plus 5. Okay, so before we even start, let's review, whoops, that's the wrong slide. Let's review this form here, right? Y, this is our function, right? And this represents our line. Okay, the m is our slope, right? That's going to be our slope is derived by our change in y divided by our change in x. Okay, x will be our x value. If we plug it in to our equation, it will spit out a y value, right? And then b is our y-intercept, so where our line intercepts the y-axis. Okay, so if you know this and you know this, you can plot the line. Let's see how you do it, right? And you can check it by dropping in an x. Okay, so let's plot this line. So we know right away that our y-intercept is positive 5. So starting our axis, we go 1, 2, 3, 4, and this is our y-intercept. Okay, this is a negative slope, right? We know negative slopes go this way. Negative slopes are that way. They go down like this. Okay, positive slopes do this. Okay, so, and it's going to be a 2-to-1 ratio. So for every change in y, it's going to be 2. Every 2 changes in y, it's going to be 1 change in x, right? Because this is a 2 divided by 1, so it's 2 up and then 1 over, right? So in order for this to go 2 up and 1 over, and to make this line go this way, it's going to have to be like this, right? So 2 change, 2 change, right? So that's going to be our slope. Okay, so with those two lines, we can kind of plot it like this. And if we want to check it real quick, that was a little fat there. Maybe you can get a fatter line. Okay, so there's my line. Okay, and if I plot, let me put in like a negative 4 in this. So 4 negative times 2 equals negative 20 plus 5 equals negative 15. Right, well, that's off scale, so let's do something different. Let's do negative 2, so when my x value is negative 2, right, multiply that by negative 2 equals 4, right, plus 5 equals 9, so I'm way up here, still off scale. All right, so let's put in I don't know, let's do it, how about like negative 2, right? So negative 2 times negative 2 equals 4, right? Plus 5, right? So this should equal 9, right? So let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, let's see. 9 negative is 4 plus 5 is 9. Right, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I guess it would be here. My line was a little bit off. Let me make it like 9. Yeah, here we go. It wasn't exactly on spot, but it's 9 there. Okay, so that is how that looks. Let me make this a little fatter. Line up all my lines, and there we go. There, now it looks a little more apparent. Okay. All right, so there we go with that one. All right, so that is that one. Maybe I'll erase my red ugly line. There. Okay. All right, so there is that one there. Okay, so now let's take another example, another line here, and it's going to be, say it's 6x. Do 6x plus 3y equals negative 3. Well, it's not in slope-intersect form, so let's reduce it and put it in slope-intersect form. We have, they're all divisible by 3, so let's do that first. So this will be 2x plus, let's see, y minus 1, or equals negative 1. Okay, so now I can go ahead and get my y value all by itself. So this is going to be y equals, well, it's going to bring over here and turn it into negative 2x minus 1. All right, so I know that in this case, the slope is still negative, and it's the same as the other equation. So just by looking at these two, the slopes are equal. Therefore, the lines will be parallel. Okay? That's a big point to know. So my Q statement, or my statement, say, if two lines have the same slope, then they are parallel. Okay? And then their inverse statement is if two lines are parallel, then they have the same slope, right? And these are both true, so this is an if statement. If and only if, okay? All right, so let's go ahead and plot this. No, I have a erasable blue. All right, so I know that my y-intercept is going to be negative 1. Okay, and it's going to be a negative line, and it's going to be a change. Every change in y is going to be one change in x. So change in y, change in x, change in y for 2 to 1 change in x. Okay, so it's going to look like that, and then I'm going to go ahead and do my best to plot those, and there's my parallel line. All right, so that is what that will look like. Okay, now let's work on something a little different. Let's plot a line that says it is, let me go to a different color here. Let's go to orange, and let's say that our orange, I'm flopping up my page cover. Okay, there we go. My orange line segment is 4y is 4y minus 6x equals 8. Right, that is my original line segment. Let me shift fonts to shorter. All right, so now I got to put it in slope-intercept form. Divide everything by 2. Right, they all have common denominator of 2, so 4y divided by 2, it'll be 2y. Right, this is going to be minus 3x, and this is going to be 4. Okay, I need to get y by itself. Excuse me. And this is going to be 2y. 2y equals, this is going to be 3 now. It goes to the other side. So the sign attached to 3 changes to positive, and this will be plus 4. Okay? This is still y. This is not y yet. It's 2y. So I need to divide both terms, both sides by 2, leaving me with y. Then here's my y equals mx plus b equals 3 halves x plus 2 plus 2. All right, so now I can extract everything I need from this equation. My y-intercept is going to be 2. 1, 2. Okay, and here I have a positive slope because my sign in front of my x term is positive. And my change in x is 3, and my change in y is 2. Excuse me, that's backwards. My change in y is 3, and my change in x is 2. Right, so it's going to go 3 up, 1, 2, 3, and 2 over, 1, 2. Okay? And then conversely, it's going to go 3 down, 1, 2, 3, and 2 over, 1, 2, giving me a positive slope. All right, so I'll connect those 2 lines. And right here is my line. That looks better than my first try, last one. All right, so let me plug in a number here to check it. Let me try, let's do x equals 2. That'll make it real easy. If x equals 2, this term will be 3. So 3 plus 2 is 5. Right? So if x equals 2, y should be 5. It's going to be 1, 2, 3, 4, 5. Perfect. Okay. So now let me look at my other one here. I'm going to say that my other equation is, we'll do 2x. I'm going to do 2x plus 3y equals negative 12. Okay? So again, I got to put this in the proper form. I got to put it in y equals x plus b. Nothing to really divide anything by, so I got to get 3y over here, keep the y's over there, and then move negative 2 stays, and give some space to put my x value, and it's going to be 2x minus 12. Oops, sorry, I made a mistake there. All right, it's 2 on this side, so it's going to swing into negative 2 on that side. Well, I can tell right now that these have opposite slopes. These have opposite slopes, so they're not parallel. They're not parallel at all. Well, anyway, let's continue drawing this line and see what happens. Right? Let's make this into y. So divide both sides by 3. Well, 3y divided by 3 is just y. And then this is going to be equal to negative 2 over 3x minus 4. Okay, well, at least I know my y-intercept is going to be 4. Right, so where's my blue marker? Blue marker here. So this line's going to intercept at like negative 1, 2. Oops, sorry, negative 1, 2, 3, 4. That's where my line's going to intercept at. And then for every change, it's going to be negative, so it's going to be going this way. It's going to be going this way. And for every change in 2y is going to be a change in 3x. Right, so let's see, a change in 2y, 1, 2, is going to be a change in 3x, 1, 2, 3. Intercepts right there. That's a coincidence. So let me double check. Change in 1, 2, 1, 2, 3. Okay, and change in 2, 1, 2, change in or sorry, changing 2, 1, 2, changing 3, 1, 2, 3. So changing 2, 1, 2, changing 3, 1, 2. I thought I made a mistake. Okay, so there's my thing. I was drawn to that point. That's I'm sure that's a psychological, that's confirmation bias there, I think. So I was drawn to that point. So don't make that mistake that I did. I did a x over y, not a y over x. Okay, so so anyway, now I can connect that line. I'm gonna double check that line with a point there. And let's see, this is gonna intercept some stuff, but that's okay. I didn't quite, this is gonna be a fat line. Okay, so that's my line there. And let's put 3 in there so it's gonna be -2 minus 4. So if x is -2 on 2, this is gonna be -2. Let's say x is 3. So let's say x is -2. Okay. So if x is -2, so -2 times 2/3 negative equals 1. Okay. Well, let's start just making -3. So -3 times 2/3 negative equals 2 minus 4 equals 2, right? So if this is -3, 1, 2, 1, 2, 3, then this is going to be -3, which is right there, right? So that is true, right? So my point is good, right? But if you notice something about this line here, this looks kind of like a right triangle, and a right angle, and it is. We could go over and look at. I could spend some time and figure out like the length, the change in x for this, and the change in y for that, and prove to you it is. But I don't want to, because that would make this thing longer, and it's already been 17 minutes, and I don't want to spend more time doing that. But it is a right angle, meaning that these are perpendicular lines. And I know that, right? I could have shown it to you earlier on, because this and this have a relationship. One, they're the reciprocal of each other, right? Reciprocal, right? Reciprocal, right? So it's like 1 over x. That's your reciprocal. There's actually a button on your computer, on your calculator for it, right? If I did 3 halves, that puts the reciprocal, it's 2/3, okay? That's a reciprocal. And it's 2 opposite in sign, right? It's positive here and negative here. If both of these conditions are met, the lines are perpendicular. Okay? So that is how you can tell if lines are perpendicular. All right? So I hope that makes sense to everybody. Less than 20 minutes. You guys should be able to figure out the workbook stuff from here on out.